As for the confidence interval, we already did it. It's stat, t-stat, paired. I'm going to change the amount of space I'm doing here because all we need is the lower and the upper that StatCrunch provided for us. So we can see the bottom number is 0.06 and the top number, 0636, if you will, and the top number is 0.0913. I just kept 5 decimal places for no apparent reason. And it would be meters per second would be the unit. Right? I'm going to ask for that as well. So I'm going to write that down because I'll add it for future. All right. Now, what was our point estimate? Well, we already found it. The point estimate was d bar, which is 0.0775. Right? We found it on the previous page. Now, one thing you could do is if you didn't know the point estimate, if you didn't find d bar on your own, we could remind ourselves that there is a formula for finding d bar. And it was on the flow chart for chapter 9, and don't worry, it'll show back up on the flow chart for chapter 11, but you take the lower plus the upper divided by 2. So we did find this with StatCrunch, but I could make a little note. Matter of fact, I will. Here, let me just segment this off. I'm going to change this problem so it takes more space here. So you could find it with lower plus upper divided by 2, which would be this is just a review of us doing that work from chapter 9, and there it is. You add these two, you divide by 2, and you should get 0.0775. We didn't need to bother because we'd already found that value, but we could do it that way if we wanted to, if we had the interval. Remember, those formulas only work if you have the interval, which we do in our case. So let me show you. If I divide by, so 0.0, oh, here. The more common way for a student to do it is write parentheses first. So if you pay 0.06365 plus 0.09135, close the parentheses, divided by 2, and sure enough, you get 0.0775. All right, what about the margin of error? Well, again, there's 2 formulas for that. There's the real formula, and then there's the other formula, right? So when you look at this, your margin of error is the back half, right? It's the t value times the standard error. So margin of error has 2 ways of finding it. It has a real formula, which is the t alpha over 2 times the SD divided by the square root of n, which, hey, we've already found SD in the square root of n. Well, we found n, but we don't have the t alpha over 2, so we'd have to do that. So this is the real formula. It's in your box on the previous page. Or we can use the kind of fake formula, right? So the easy formula that we learned in chapter 9 is still holding true. So let me go grab the flow chart from chapter 9. It's right here. It's the upper minus the lower divided by 2. So we could do that. So we could say upper minus lower divided by 2, and that'll work great for us because we already know the upper and the lower values because we already found them right here. Right? This is your lower value. You always put the lower one first and then the upper values right here. So we could take 0.09135 minus 0.06365 divided by 2. All right, so let me go grab Desmos. And they are different, so you want to make sure you catch that there's a difference here. You put the upper first and then the lower. You close your parentheses and you divide by 2. And we get 0.01385. Oh, if you're interested, that would be meters per second as its unit, and this would be meters per second as its unit. Everything would have the same unit of meters per second because we were measuring velocity of these swimmers, how fast they're swimming. All right, so now how confident are we? Let's see. We are 95% confident that the true average difference, right? So when we first gave you that script back in chapter 9, we just say parameter, right? But it changes for each problem. In this case, we're talking about the average difference, right? These are differences, and it's the average of those differences. So the true average difference in swimming times, or I guess in swimmer's maximum velocity, in swimmer's maximum velocity, which is the fastest they swam, is between 0.06365. Actually, let me kind of throw in that wetsuit business just real quick. Velocity, difference in swimmer's velocity, wetsuit versus no wetsuit. I'm just going to kind of throw that in there because that explains what the difference is. It's the difference between wearing the wetsuit and not wearing a wetsuit is between 0.06365 meters per second and 0.09135 meters per second. Does this interval suggest that there is a significant difference in swimmer velocities? Yes, definitely. Let's talk about why. Significant difference. Just remember, in this chapter, the null hypothesis is always that the two groups are the same, or that the difference is zero, right? There's no change, no difference. Right? That's always the null hypothesis. So you have to ask yourself, hey, look at my interval. My interval is from 0.06365 to 0.09135, right? My interval is right there. The point estimate is right in the center, by the way. D bar is right there, which is 0.0775, right there. No difference would be 0, but 0 is over here, right? That's where 0 is. I should just put it right there, right? 0 is right there. And 0 is not contained in that interval, right? And that implies that there is a significant difference, right? So let me write that down. Yes, the interval suggests there is a significant difference. Because 0 is not contained in the interval. It's not between the two limits, right? Between our lower and upper. That's what I mean by contained. Right? 0 is not between them. 0 is over here, which is the same thing we said in section 11.1. If there's going to be a significant difference, it means that 0 is not in the interval. Right? It's not between the lower and the upper. Right? That's what this means. In the interval means between the lower and the upper. Right? It cannot be between those two values. Or put it another way, if 0 is in between those two values, there is no significant difference. Right? If 0 is between your lower and upper limits, right, your lower and upper limits of your confidence interval, there is no, that implies there is no significant difference, or there is not a significant difference. And that's the exact same thing we said in section 11.1, and we're going to say it again in 11.3 to be perfectly honest.